Right now, KIC 8,462,852 is still dimming, flickering on and off like something is deliberately blocking its light, and astronomers at Yale have no way to stop it. It's happening again as you watch this. And what they found buried in 8 years of brightness data is the part they still won't fully explain out loud. But here's what nobody is telling you. 950 light-years away in the constellation Cygnus sits a star that looked completely ordinary. Then in 2015, everything changed. A citizen science team scanning NASA's Kepler telescope data found something wrong. This star wasn't just dimming a little, it was dropping by up to 22%. For comparison, a planet the size of Jupiter can only block about 1% of a star's light. Whatever was crossing in front of this star was enormous. Astronomers gave it a name, Boyajian star, after the scientist who found it, but online it picked up a darker nickname, the alien megastructure star, because nothing natural seemed to fit. Here's where it gets strange. The dips weren't regular. A real planet orbits on a predictable schedule like clockwork, the same dip every few days or weeks. This star's light dropped at random intervals, sometimes deep, sometimes shallow, sometimes lasting days. Then, buried in the archival photographic plates, researchers found something worse. The star had been slowly, steadily fading for over a century, not in sudden dips. A long, quiet, unexplained decline, two separate kinds of dimming, one fast and jagged, one slow and relentless. Nobody could find a single cause that explained both. And when Harvard astronomer Avi Loeb looked at the data, he didn't rule out the impossible. He said an artificial structure, something built, remained on the table. So scientists went looking for the obvious answer. A swarm of comets, they said. A cloud of broken-up comet fragments drifting past the star in an eccentric orbit, blocking the light unevenly. It sounded reasonable, comfortable even, except the math didn't hold up. To cause dips that deep, you'd need an almost impossibly dense swarm, hundreds of comets, tightly clustered, all passing at once, over and over for years. And comet dust reflects a specific way. It should redden the starlight as it passes, scattering blue light more than red. When researchers at Louisiana State checked the color of the dimming in 2018, using multiple telescopes at once, they found something odd. The star dimmed more in blue light than in red. That's backwards from what a dust cloud should do. It pointed instead towards something opaque, something solid, something blocking light evenly, the way dust simply doesn't. And that finding still hasn't been fully explained. Now here's the part they're afraid to say out loud. If it isn't dust, and it isn't a planet, and the object is large enough to block nearly a quarter of a star's light while moving on no fixed schedule, then what exactly is out there? Some researchers have proposed a shattered exomoon, a moon torn apart around a planet we can't see, its debris still spreading, still tumbling past the star in long, ragged clumps. Others point to an interstellar cloud the star is slowly passing through, something we've genuinely never observed anywhere else. But even that theory has a problem. It doesn't explain why the fast dips keep happening on top of the slow fade, two different mechanisms, stacked on top of each other, both still active. In 2019, one of the deepest dips ever recorded hit the star with almost no warning. Telescopes worldwide scrambled to point at it in real time. They caught the color data. It still leaned towards something solid. And the slow fade, the century-long dimming, is still going, still measured, still unaccounted for. Whatever is out there hasn't stopped. It hasn't been identified. And it hasn't shown any sign of finishing whatever it's doing. Because here's what worries astronomers most. If natural explanations keep failing this specific test, the comet swarm, the dust cloud, the simple orbiting planet, then every rule we use to interpret starlight from thousands of light years away needs re-examining. We assume dimming means dust. We assume irregular means chaotic and meaningless. Boyajian star breaks both assumptions at once. And if one star can hide something this well, blocking light in a pattern we can't model, then how many other boring stars in Kepler's data are doing the exact same thing unnoticed because nobody thought to look twice? This star didn't just reveal an anomaly, it revealed a blind spot in how we search the sky at all. So the dimming continues. No fixed pattern, no accepted explanation, no sign of stopping. Somewhere 950 light-years from here, something is still passing in front of that light right now, while the world's best telescopes watch and wait. What do you think is out there? Tell me in the comments.